Hello everyone and welcome to another problem solving session Special Maths Academy. And today's video we are going to cover two problems from the Senior Mathematics First Round Olympiad 2020. So those are the problem 6, that's the first one written as you can see, and the problem 12. So we'll start with the problem 6. One of the following cannot be factorized into polynomials of multiple variables with integer coefficients. Then these are the options. So basically 4 out of these 5 options can be factorized and 1 cannot be factorized. So this question will be really straightforward if we are used to a lot of factorization and identities. I believe we must have seen something like this before, that if you have that this can be factored into this. And to prove an identity is really straightforward. You can just expand both sides out and you see that everything will cancel out and we get so that's why it's even called an identity, when both sides are like exactly the same for all the variables. So to prove that this is true, now the pairwise product, you can just expand this right hand side. Since the right hand side is more complex than the left hand side, if you multiply the right hand side out, a lot of things will cancel out and you actually only be left with this. You can verify it. Then so it means that this second option can be factorized, so it's not the answer. Then this third option now, what's the sum of coefficients? 1, 2, 3, 4, 5, 6, 7, 8. So the sum of coefficients 8. So we are to be expecting let me just give some ideas of how we can somehow guess what the expansion should be. It's not really a way to exactly find, but just to 1, 2, 3, 4, 2 have an idea of what we may be expecting. So like the sum of all the coefficients in this in this option C is the sum of coefficients 8. So in our expansion, we're like to be expecting like to have some brackets, like a couple of brackets, so 3 or 4, such that like when you multiply each of the products of the sum of coefficients in each bracket together, we're to like be expecting 8. So because by like trial and error, and because like this this function or this expression x squared y plus y squared z and all that, this option C is symmetric in the 3 variables. So us guessing something like this, x plus y, y plus z, z plus x. Okay, let me not write equals to. If you get something like this, that is actually a good guess. So why is this a good guess? Because the sum of the variables, when you expand everything out to be like the product of the sum of variables of each of the brackets, so that is like 2 times 2 times 2, and that is also equals 8, which is also the sum of variables here. So like this, why this is a good guess. It doesn't automatically mean that this is the factorization, and also like this is also a good guess because this factorization is symmetric in x, y, and z. Same with what was given to us in this question, symmetry in x, y, and z. But actually, if you expand this expression factorized here, you actually get what is on this left hand side. But as I said, it's just like a guess. Like there's no systematic way of like just knowing automatically. You have to like have already been familiar with it before time. So these two things are equal. So it means option C is not the answer. Then option D, x squared y this whatever. So the sum of coefficients here is 9. So we should be expecting like some factorizations, maybe in terms of brackets, that like the product of the sum of coefficients of the first bracket and the second bracket to be 9. So we're expecting like 2 brackets to have 3, 3. Or either we'll have one bracket having 1 and the other one having 9. But 3, 3 looks like more natural. So from that, we then be able to guess that something like this I'm saying, like I said, I'm saying guess. I'm not like saying get. Like you can't really get it exactly if you have to like actually test it out. So like now, this polynomial or this factorization here now, it has the property that the sum of all the coefficients of the term after I expand it out is 3 times 3. That is 9. So it satisfies this also 9, and this is also symmetric. This is symmetric. So it satisfies those 2 key properties. And actually, when you expand this out, you actually get option D. So it means option D can be factorized. So it's not the answer. Then option E, the sum of coefficients is 0, and it's the only expression here that is not necessarily, it's not symmetric, it's cyclic. So any factorization, if this is to have a factorization, we are to like the factorization, like the brackets are meant to actually be cyclic. So The most, and also the sum of questions is 1 plus 1 plus 1 minus 1 minus 1 minus 1, which is 0. So the sum of the questions of the factorization should be 0. So this is like the first thing I would think of. Yeah. Or negative of this. Either this plus or minus this. So, but when you check it properly, you see that the one that works will be minus x squared. The one that works will be actually negative of this. Or if you don't want the negative sign to be outside, you can just like swap everything and get y minus x, z minus y, x minus z. So when we factorize this, when we expand this out here, we actually get the fifth option here. So it means the fifth option is not the answer. So we have gotten 4 factorization. We have gotten factorization for B, C, D, and E. And we haven't gotten for A. So actually, like this guessing stuff, like this, it can be used to like guess a factorization, but it's very difficult to like prove that something doesn't have a factorization. So that's why we just like try to look for the ones that have the factorization. So as you can see, 4 have the factorization, and this is an exam, so it should have an answer. So the answer should be option A. So option A doesn't have a factorization. So that is the answer to this question. Option A, that is problem 6. The answer is option A. So now I'll go to the next question, number 12. Given A and B positive real numbers, what is the value of x that minimizes this? So this just looks like AMGM, like definitely. So what does AMGM inequality say? It says that if you have 2 positive numbers, m and n, let's say they are positive real numbers or non-negative. 0 can also be a number. Let's just say positive. Let's just say non-negative. Then when you add these 2 numbers, if you find the arithmetic mean is given by this, is at least the geometric mean of the 2 numbers. And yet geometric mean is defined because it's positive, so the square root of positive number is well defined. So this is what the AMGM says, and it's very easy to prove this. Like this is inequality is equivalent to this. Leave it to the readers to show why it's equivalent. You can just expand both sides and rearrange the terms. You easily get that these 2 things are equivalent. And we all know that all perfect squares are non-negative, so all perfect squares satisfy this inequality. And yeah, so now we just apply AMGM here. So but how do we use AMGM to solve this? It looks like it's a good idea if we apply AMGM to the numerator. So when we apply AMGM to the numerator is a plus b x raised to the power 4. By AMGM, this is positive, and this is also positive. B is positive, so give it to us in the question. And x raised to the power 4 is at least non-negative. So yeah, these 2 properties, like that both of them are non-negative, they are like the necessary conditions for us to be able to apply AMGM. They're actually necessary and sufficient for us to be able to apply AMGM. Yeah. So now by AMGM, this is at least 2 times square root of the product of these numbers. That's a times b x raised to the power 4. So this equals to 2 roots ab x raised to the power 4. X raised to the power 2, sorry. Okay, yeah. So now what does this mean? It implies that you can now divide both sides by x squared. So it implies that ab x raised to the power 4 over x squared. Why can we do that? The sign won't change. Why? Because x squared is non-negative. But actually, if x is 0, this equation won't have been defined. So I think the question could have written x is not 0. Or we are just assuming that x is not 0. So we can divide both sides. It's not negative. So the sign of the inequality won't change. So it means that this is at least 2 root ab. But that's not actually what the question asks us to find. The question says we should find the value of x that makes this minimum. It didn't say we should find the minimum value of this. So now we have to go back to this AMGM here now. So what values will make equal? So this question just asks us basically at what point or at what value of x will equality hold. So for this AMGM now, we know that this inequality is true, like all perfect squares are non-negative, so they are greater than or equal to 0. So at what point does this inequality hold? So what we mean is like at what point is this equals to 0? So square root of m minus square root of n, I'm writing a different pen. Square root of n minus square root of n squared is equals to 0 if and only if what is the base of this power is 0. That's only square root of m equals square root of n. And because both are positive, you can square both sides. So that will be if and only if m is equals n. So equality holds if and only if the two terms you apply the m gem to are equal. So now equality here holds, and equality is like what gives us the minimum value. Because this is greater than or equal, so the minimum value is this. And equality holds at this minimum value when the two terms we apply the m gem to are equal. So what two terms do we apply the m gem to here? Apply m gem to a and to b x4. So when these two are equal, a equals to b x4. That is x4 is equals to a over b. So equality holds when x is equals to a over b raised by 1 over 4. So but we don't really have this in the option. We have it's written in terms of indices. So 1 over b can be written as b raised by minus 1. So this equals to a b minus 1 raised by 1 over 4. So this is the answer. Equality holds at the minimum value. And that minimum value of x is equals to a b inverse, the fourth root of a over b. That is fourth root of a times b, 1 over b inverse. So that is option B. Or actually plus or minus, yeah, because because we're not sure if x is positive or not. I forgot about that. Yeah. So x4 is a positive number. So x can either be positive than number or negative than number. So it's actually plus or minus. So that is option B. Yeah. So these are the two questions we solved for today, and I'll keep on uploading the rest. And this is all we have for today. Goodbye, and I'll see you soon.